In this example, I will explain how to establish the DID communication channel between Alice and Faber using Hyperledger Aries, and for the ledger, Hyperledger Indio will be used. So first I need to start the ledger. Now right, so now I need the command to start it. So I will start the ledger now and check the uh, Genesis ledgers. Now the network has been started, but if I check the ledger immediately, it will not show anything because it will take some time to start. So I need to wait around 1 minute. Now in the meantime, I can start the Alice and the Faber code. I will not start, but I will at least take the preparation because it will take some time. Now, where is the Hyperledger agent code exists? Now this is the code that is exist inside the demo, and inside the demo there is the folder called the runners, and inside this runners program we have the Alice and the Faber. Now what Alice will do is that when the Alice code will start, it will not record any of its DID and the public key, private key. Of course, private key will never record in the ledger, but it will be all generated. But in this case, nothing will be recorded in the ledger for this example. Now, for Faber, what it will do is that it will again for Faber it will also will not record any of the information in the public ledger. Instead, what Faber will do is that it will generate a PR DID. It will generate a PR DID for the Alice, and Faber will transfer this PR DID to the Alice and ask the PR Alice to communicate with the Faber using this address. Now, and through it will establish a DID communication channel. So agent will generate on PR DID for the Faber and on PR DID for the Alice, but Alice do not have that address. So what Faber will do is that it will transfer it to the Alice. But in this case, they cannot do it automatically. So I mean, as a user, I will transfer this address from Faber to Alice, and Alice and Faber can both communicate the channel. Now, okay, so now I think that it's we can view the ledgers. Yes. Okay, let me restart it because it's already showing 10. I mean, it's supposed to show 5. So let us start once again. So first I need to stop it. Right. So again start. Now when the ledger will come online, now what it is going to show. Now we can see already that it has 5 entries. It will show 5 records. Among these 5 records, one will be the trustee. Now trustee is the higher privilege level, and we'll see the role value will be 0. It can add stewards and other trustees. Now what stewards able to do? Stewards has the permission to add new records in the ledger, and the trustee has the permission to add or remove new stewards. So steward has role value is 2, and that is the 0. So in this network we have on trustees and 4 stewards, and to write something we can use any of these trustees, is any of these stewards DID and a public key to establish contact with him. Now in this case we will not do it manually, we will ask the Aries agent to establish the connection and he will do that. So hopefully now we can see that here we can see that we have the 5 entities, and if we check closely we can find that, let us find the role. Here is the role 2. So role 2 means that it has the steward, and here we can see this is role 0, so it means that he is a trustee, and we have 4 stewards similarly, right? So let's start then the Alice code. So we have this instruction set here. So first activate the virtual environment in Python. So I have already installed, so I can just activate it. Right, so now it will start the Alice code. Right, so code has been started. Let's just discuss that which informations are available here. Here we can see that our Alice code has been started, and Alice is actually very passive in this example. He's not doing anything. He's just waiting for a invitation, and then it will establish the connection. He's She's waiting for the invite details. Okay. So, but we can check that in the ledger nothing has been happened, and there is no update. So previously it was 5, again 5. No update. Now there will be significant change when we'll start the Faber code. So let us start. Now when favor code will be executed, then 4 new entries, uh, 4 or yes, 4 new entries will be added in the ledger. So it will become from 5 to 9 entries. Now number 6 entry will be added, that is the Faber agent's DID, it will be added. So and next is that 7 entry will be the endpoint of this uh, Faber agent. Now, when DID is actually added in the ledger, this transaction is called the NIM transaction. And when the endpoint or any other attributes are added, these are called the active transaction. Now, number 8 and number 9, we do not need it at this point because we just want to, at this point we are interested to establish the DID communication channel, but we can ignore it for now. But uh, this is an example, but it's for this reason it will show that in the 8 entry will be the schema transaction. It will define an example degree schema, so it will show the name, date, date of birth, this type of information, attributes, I mean the attributes of the credential will be visible. And the next will be the credential definition transaction. It will show publicly available informations to use to validate the credential, in this case degree credential. So we can start now. Right. Here you can see that it is waiting for the connection and it also generates some important information. Let us discuss from the start. Here you can see that the code is, the home folder is this location, it is situated, and the user is this person. And this is very important because this problem is still I could not solve it. That is the wallet storage configuration that I'm trying to configure. But in this example it would be really nice if they actually set some kind of configuration that would be easier, but unfortunately they did not do it. It is shown the non value, and the storage type, that is also non value. Now storage configuration means that the what kind of parameters it will use, that, and if it is a persistent or in memory. In this case it means that it's temporary wallet. And the storage type is that there are two types of storage type. I mean, we can either use the Oscar type or the indie type. Now Oscar is the newest, and that is, both are supported at this point. What I understand, that both are supported by the Aries agent, but Oscar is the newest. So now we can see that this is the, now when this program starts, it will fast create, very fast task it will be to create the Aries agent. In this case we are calling it the Faber agent because Faber, the program is actually using it, that so it's called the Faber agent, but in reality it is actually the Aries agent. So Aries agent is actually created at the very beginning using some preset parameters. Now when it starts, it will generate its own DID and set a private key and a public key. And all these informations are stored in the wallet. So it also creates its own wallet and stores this information in the wallet. And then agent stores public key and the DID in the ledger. That we have already discussed. And if we check this thing in the ledger, we can see that the entry jumped from 5 to 9. And if we actually check these entries, This is the alias Faber agent or the Aries agent, you can call. And this is on entry, and this is the five, and then it added the endpoint. Here you can see this is the endpoint, that is some web address, right? So now we can establish the communication. So what is the invite informations that consist of the PRDIDs? So all these informations are added here, and we can just copy these things. Okay, so it starts from here to here, copy, then paste here. Here we can see the connection has been established, and we have these three options: send message, input, invitation, or the exit. Similarly, Favor also does the same thing. In this case, it has more options because it can also issue credentials. But right now, we will only do one thing, that's the send message. So we send some message here: hello from Alice. Here you see that the Favor actually received this message. So it also sent a message like hello from Favor. And it also received this message, hello from Faber. So this code is actually working. So I can now exit this thing, and here is also exit this thing, right? So in this case the communication is actually working, but I want to understand that how actually step by step how things are progressing. So to test this thing, I have actually created a new example. In this case, it will do only three things. One is that it will start the Aries agent, and then it will just randomly generate a specific DID and set a public key, private key for a entity. It could be patient, it could be APC, and it register in the ledger. So I do not need to reset the ledger, but for clarity I'm just going to reset it, or we can continue from this here. There is no problem, there is no requirement that I need to update it. So I'm just doing it just for clarity, that I will just stop it once more. And then I will start again. Right, give some time to start the ledger once again. I will just start my code. No, not that. Now, this is the code Favor Mini because it only has three steps instead of so many steps. Now, so first step is that it needs to it takes some input from the user if it has some pre-existing parameters, and that is defined in the agent container program, and it's imported the argument parser. So where is the agent container program is actually exist here. Uh-oh. This is the agent container. In this program, it's a long program, it's a 2000 line code. It inside it is defined, and there is another important program that's called the agent. So here it is defined with, and user, if user wants, he can also give new parameters and it will override the default parameters. This is going to happen in the step 1. And step 2, we are actually starting our agent for the very first time, and as soon as it starts, it does uh, if first it generates its own agent's own DID and the public key and the private key. Then it generates its own wallet, and then it stores this DID, private key, public key inside this wallet. And then it will again access the wallet, take the DID and the public key and register in the ledger. So after step 1, it takes some input. Step 2, it starts its own agent, and then we also set more in the more parameters in this context. And then I mean, what is most is important here. The important part is that we have the agent. Agent is actually a tool that is running. Now, as a programmer, our own code will need to contact with the agent and give instruction. So, and how can we give them the instruction? From the admin port, because we are the admin, we as a user, and from this code we will give instruction. Now, what will give instruction? We will tell the agent, now as right now you are created, you are working well. Now create a set of DIDs, set of private key, public key for the another entity. First do your own, now do for others. It could be APC, it could be patient, it could be another entity, it could be Faber, it could be Alice. So this is done. Then it is, here we can see that generate a new, we are giving instruction to the agent, and then we are taking some printout that how it's going, and then we are instructing him as a name transaction store this generated DID and the public key in the ledger. So we will see 3 entries, 2 entries for the Aries agent and another entry for the DID of the another entity. So now it is started, so we can now check this thing. Okay, it's called the Faber Mini. Faber Mini. Right. First, let us check the ledger, how it's looking for now. Right. So we have by default 5 entries. Now, as soon as I enter it, it will become 8. So so here you can see that everything is done, and this is the, for that entity it could be Alice, it could be Faber, it could be patient, and for that entity our agent generated this DID, and this is the its public key, head key is the public key, and this is a name transaction, and everything is added in the ledger. And if we can check it, we can find out that yeah, it's working. Here you can see that 8, and here you can see that um, okay, here we can see that the alias is Faber. In this case the entity name is Faber, not patient. It's in this case it's Faber, but we can just update it, and it could become any entity. And here you can see that we have already defined alias Faber. This is where everything is done. So if we really want to set for another entity, we can just update it and it will work. Now this is the what. Okay, so here it is. So we have the DID for Faber. We can see that the 8B8M, this is the 8B8M, and Bharki is the 4UOO, 4UOO. So yeah, it is stored inside the ledger. So it is working. Now, what is not working? Not working is that the the wallet is still, the wallet is created. Otherwise, I mean, if wallet is not created, it will not stored in the ledger. So is wallet is created, but the wallet is a temporary wallet or in-memory wallet has been created, not the persistent type that we want. Still that is not there. That is the problem, and we can check that existence of this wallet, if it is actually exist or not. Now, it will be, the folder is actually empty. That is the problem. Yeah, that's the thing, it's not exist. Or we can also check from here. Mm, yeah, it does not exist. If it exists, it could show us the database SQLite database, but it's not there. Because why it is not there? Because by default, the parameters is set such a way that it only generates the in memory wallet. That is the problem. So it exists, it works well, but as soon as we stop it, the in memory wallet will be vanished. So yeah, I mean, another program cannot read this thing because the wallet is not persistent. That's the problem. So I tried to set some parameters, but it did not work. But at least it shows some parameters of the wallet, but it is still not persistent. So this is the Faber wallet check. This is the code. This is an experiment. I tried to override the default parameters of the what is given, but the thing is that it did not work. That is the problem. Still I'm trying to solve it. It is working, everything is working, but the parameters I am overriding, it's not work. But at least it will show that what type of wallet is actually created. Okay, so let us run this code again. We can check the, okay, we can have to check the, okay. Mm. Okay, but laser is not the thing we are looking for at this point. We just want to run this code, right? So for this running of the code, have I have written down the command Faber wallet, Faber wallet check, and Right. So these are the parameters I'm setting. That wallet type is Askar. The wallet name is Faber wallet, and I have set a wallet key, and this is the seed value of this wallet. From this seed, the private and the public key will be generated. So right, the code is executed successfully. There is no error message, so it means that everything is working well. But here you can see the DID is currently in the wallet, so we can access the wallet thing information. That we can see that the wallet, inside this wallet we have this DID, and we have this address, and that is also stored in the ledger. So here you can see that DID is the QW, and the where key is the DP8. So DP8. Here we can see the DP8 is actually added. This is the var key, and this is the alias favor mini. So this is working fine, but the problem is that the wallet has not been created. So we have set these parameters, and we can see that initialized demo agent mini with credential type in the parts configuration, ask our favor wallet, this thing, but it's not the the wallet is still not visible. That's the problem. And when wallet is not visible, it means that it's not persistent wallet. So let us search it one more time. Yeah, nothing is here. They are supposed to be SQLite database, so it means that the default. I mean, I have given some parameters, but it did not override the default settings. That's the problem, because the default setting does not allow me to create a persistent wallet. I'm giving him the command, but still it's not listening. So that it means that either two things. One thing is that I did not give the right parameters, and the main challenge is that there is no documentation, and there is not a single example that would be really helpful, but that is not there. So I have to use some trial and errors to make it work. So